Welcome back. In this section, we're going to cover the Google Application Engine, known as GAE. We're going to cover a quick refresher and overview of what GAE is. We're going to cover why you would use GAE, the design considerations that you need to look at when you're architecting a GAE solution or component, and the considerations you want to take into account when running a GAE solution. So, straight into the overview. What GAE is, what it's good at, what it isn't so good at, and where it sits in the GCP lineup. Google Application Engine is Google's managed platform for developing and hosting web applications via code, also known as Platform as a Service. Very simply, you write your code, providing the libraries in Docker containers, and Google does all the rest for you. You can write in a variety of languages. You can use a custom runtime environment if you want, and Google even provides you with a services ecosystem of developer tools, including Cloud Debugger and Error Reporter to assist in diagnosing and fixing bugs. App Engine sits very neatly in the middle of the scale of Google's levels of management. Google provides and maintains everything but the application. Under the hood, Google takes care of all the infrastructure and runtime environment, which is to say the hardware, hypervisor operating system, the app hosting environment, unless you provide your own. That includes all of the setup, provisioning, scaling, maintenance, patching, and security for everything below the code that you deploy. You remain responsible for all aspects of the application that you write: deployment, maintenance, monitoring and logging, and security, and that of any custom runtime environment that you provide. So why would you use GAE? As I said before, it's a managed platform service. You just add the code. There's no virtual machines or operating systems to deal with. Google deal with all the scaling up and down for you. You pay for just what you use. If you're not running anything at this point in time, they don't charge you for anything. You have the usual selection of languages you can write in, and you can provide your own language runtime for other languages. You can provide all libraries and frameworks that you want to use via Docker containers, and it's pretty portable. If you've already got your stuff in Docker containers or as code, then you can move it to another hosting environment if you choose. All this together means that App Engine is a great option if your business involves deploying code, particularly if you use one of their default languages. It takes a lot of the pain out of the application hosting since Google does most of the work for you, leaves your software developers free to do what they do best, writing the code and concentrating on making your application as good as it can be. This can be particularly useful if you or your company haven't already invested in physical infrastructure and a support team, maybe if you're just starting up, but is equally relevant to any large enterprise looking to expand, move off their own infrastructure, or just make their workflow more streamlined. So why wouldn't you use GAE? Well, obviously as a bring your own code option, it's only really suitable if that's what you're looking to do. You have to create and support an application. If you want a pre-provided application or function or looking to host an operating system or an executable, then other GCP options are going to work better for you. It's a managed service, so it can be more expensive. It's a common thread for cloud functions. You're making a judgment whether Google manage their infrastructure better, cheaper, or make it easier for you to use than you could do yourself. The SLAs. Check out the SLAs for what Google are offering and make sure they match your requirements. Unless you're a very large customer, in which case see your sales rep directly. They're not going to change because you want them to do something extra. And trust. As a common theme for cloud computing, you're putting your trust in Google as a vendor. You're giving them your source code, trusting them to keep it safe, secure, run it properly, and continue to do so for as long as you need. There aren't as many mitigations you can take there as there are with, say, Compute Engine, where you could easily move your VM around. So the design considerations that you need to take into account once you've chosen GAE. Firstly, the language choice or custom runtime. That's going to be the basis of everything else you build. The harmony of your internal processes, development tooling that you want to use, security and compliance basics. Your first decision with GAE is which kind of environment to use. GAE has two types of environment, standard and flexible, each with different pros and cons. You can use one or the other, or both, depending on what combination suits your application best, and you can even migrate from standard to flexible at a later date if you need to. The standard environment is the simplest, hosting your application within a sandbox. It uses Google-provided runtime environments, so you have to use one of their supported languages and the version of that language. There's limited opportunities for including your own frameworks, and you pay per hour. The flexible environment hosts your application on a Compute Engine VM within a Docker container. Within that Docker container, you provide pretty much whatever runtime environment you wish, which means you can also run pretty much any language and any version. You can also add any external frameworks you choose, even those that include native code or a binary executable. Note that, unlike the standard environment, you support, maintain, and secure what you provide, and that includes the runtime environment. Usefully, your application can also access other resources or services from within GCE. The payment structure is also different. As I said before, the standard environment charges you based on the time you're using it and the degree of scaling, whereas the flexible environment charges you based on the underlying Compute Engine resources. That means you pay per CPU, memory, and disk. GAE is all about the code. There are far fewer choices to be made with respect to other Google offerings versus, say, Compute Engine, and these mostly focus around your code. Your first decision here is to choose what you want to write your application in. If you want to use one of the supported applications and languages, you can use the standard or the flexible environment, subject to other constraints. But if you want to use something else, you still have the option of creating your own custom runtime environment on the flexible environment only. Within the flexible environment, Google natively supports Python, Java, Node.js, Go, Ruby, PHP, or .NET, which means they have documentation available, and depending on what you're paying for, will provide assistance if you have problems with their service, although not with problems with your application itself. However, you can go it alone and run any language that you can create an application environment for. If you want to use frameworks with the standard environment, you'll need to be using a smaller subset of the supported languages and versions. For example, you cannot do this for Python 2.7 or PHP 5.5. The fine details of how to build a custom runtime environment is out of scope for this course, but just an overview level, you just have to provide an app.yaml document to describe your runtime environment to App Engine, and a Docker file that internally configures the runtime environment. There's some links in the notes. Digging down a little beyond the choice of language and environment, there are other differences in how the two environments function, and hence what sort of app they're suitable for. Standard scales quite quickly, in the order of seconds. It's great for applications where you might experience unpredictable traffic spikes. Conversely, Flexible has to provision Compute Engine resources to scale. This takes time. It's more in the order of minutes, hence only well suited for constant or at least predictable traffic. With the standard environment, if you have no activity, you pay nothing. With a flexible environment, you must have at least one running GCE instance, which will incur cost. Standard has restrictions on access to disk within the GAE sandbox, depending on the language and version, although that doesn't preclude giving the application access to storage outside of the GAE environment itself, say cloud storage. Flexible always gives you access to an ephemeral disk, and one that's initialized every time the VM is started up. The standard environment doesn't include WebSockets if you're looking for fine control over how your app communicates, although there are some language-specific proprietary alternatives in some of the languages. Finally, there are also restrictions on the use of background threads in the standard environment, and background processes cannot be used at all. This isn't a problem for Flexible. There are other differences, but they're down in the weeds of fine detail and not required for this certification. But check out the documentation if you need to know. There's a link at the bottom there. Now on to resilience. GAE is a regional resource. Your app runs within a region. Google manages the redundancy across all of the zones in that region. GAE isn't available in all regions, and you cannot change your region once chosen. If you need global reach or redundancy and resilience outside of a region, you can't do that directly with GAE. You'd need to have make your application region aware and manage that yourself. Just a quick note on how you structure your application within GAE, as it impacts some of the next topics, particularly the Google Traffic Management Services, traffic migration, and splitting. You create an App Engine application under a project. When you create your application, you choose a region, and all of your application-related resources are created in that region. Each app has at least one service, and each service can have one or more versions, subject to billing limits. Each version can have one or more running instances, and there's some more information on structuring your web application in the link in the notes. Now, once you've set up your application structure, there are various ways of managing how the traffic is routed to your application. Traffic splitting is a method of dividing your incoming traffic between different versions of your application. You can route to a single specific version or split the traffic between two or more versions. This is useful when comparing versions or controlling a rollout of a new version. Traffic migration will switch traffic from whatever versions are currently receiving traffic to whatever version or versions you specify. It can be done nearly instantly, or you can configure it to gradually switch over what's called warm-up requests. Warm-up requests essentially cause your app instances to load in advance of traffic actually being moved, rather than only switching on or scaling out as the live traffic appears. Warm-ups are just a blank GET request to _AH/warmup, and requests incur the same hourly charges as normal requests, so this costs a little more. The trade-off is in low latency for requests as your real traffic switches over. Note that your developers will need to code the warm-up handler so that your app does whatever it needs to get itself in a fit state to receive the live traffic. Both can be done and configured either using the Cloud Console or within the admin API. If you need storage to go with your app, you can choose one of the usual storage options. See the Storage and Databases section for long-form details. As usual, this means you can choose one of the Google options as shown on the slide, or you can use another cloud provider, third-party provider, or use your own on-premises option. Now, using a memory cache is a way of speeding up common database queries, session data, user preferences, etc. Anything where you might want to get repeated access to the same values, usually a small subset of whatever you have in persistent storage. Caching, if implemented correctly, will result in fewer reads from the more costly and slower durable storage. Google offers a couple of options and they both use the same API. Shared Memcache is the free default for App Engine applications. Provides cache capacity on a best efforts basis, subject to the overall demand of all the App Engine applications using the same shared Memcache service. That includes other people's. Dedicated Memcache provides a fixed cache capacity assigned exclusively to your application, billed by the gigabit hour of cache size. Since you own the cache, this means that your app to cache performance will be more predictable. To choose whether to use a Memcache or to choose between the two options is entirely based on the performance that your application requires and the pattern of your data accesses. If your data access is random, a cache won't help, unless you can fit your entire dataset into the cache. If you have flexibility in your access latency, then the free shared cache may save you money, but if you want steady, reliable access, then paying for your own dedicated cache is the way forward. For a bit more information on how to use Memcache, you can follow the link at the bottom. And security and compliance. See the security module for more details on the common themes, but specific to App Engine security are the App Engine firewall, which you should set up to control traffic into and out of GAE, access control and user authentication, control who or what has access to your GAE services, and which of your cloud services your GAE application can access. This includes things like service accounts. And you are, of course, entirely responsible for security in the application itself, as well as the runtime environment if you provided your own. In terms of development tools and assistance, Google provides a series of useful additions to help your developers use GAE. Extensive documentation for each of the supported languages. There are language-specific code samples, libraries, tools, all hosted in GitHub. And there are plugins for build automation tools like Maven and Gradle, and for integrated development environments such as Eclipse. See the language-specific documentation pages in the first link. Now, harmony with internal processes. This mostly falls under Section 4, Analyzing and Optimizing Technical and Business Processes section of the certification, although it impacts on all of the other areas too. Again, we cover this in greater details in later modules. Unless you work in a one-person environment, there'll be various people or teams within your business who have varying stakes in your design, have requirements for what or how you do things. Typically for a large enterprise, you might need to involve finance and asset management, internal audit, marketing, users, senior management, business owners, security, compliance, maybe even some of your subsidiaries, partners, vendors, and suppliers, maybe even customers. For GAE in particular, because you're cutting code, your key stakeholders will be your software developers. You need to work out how you're going to integrate with their software development lifecycle, continuous integration, DevOps, test and validation, application development, all different ways of specifying or thinking about how code turns into a service for the users. This will need to include their tools as well as processes. In the previous slide, we detailed a few of the ways in which Google tries to make it easy for you and your developers. But if they're not using those specific Google tools and not willing to change, then you have some extra work to design around whatever you've already got. Note that this slide is just showing some common examples of the kind of tools you can combine into a develop, test, and deployment process. It's not meant to be an accurate or complete picture for doing so, nor any particular recommendation for the tools themselves.